Hi there, welcome to the podcast on inverse function skills. I'm going to introduce functions and teach you some skills that go along with it. So first of all, inverse function is a function that undoes another function. So for example, let's say I had a function f of x that this function just added 1 to any number that I put into it. So that would be x plus 1. So my inverse function, we'll call it g of x, would undo that. So g of x would take any number and subtract 1 from it. Pretty straightforward. So for example, let's say I put the number 5 into f of x. So f of 5 equals 5 plus 1, which equals 6. And oops, I wanted to undo that. So I do my inverse function, g of 6 equals 6 minus 1, which equals 5. As you can see, my input of my first function and my output of my inverse function are the same, 5 and 5. Technically speaking, when we write an inverse function, we use a special notation. I wouldn't call this g of x. I would say this is f inverse. F with a little negative 1. So this would be f inverse. It's read f inverse. So another example, I'm going to use some pretty straightforward examples to begin with, would be, let's say I had a function g of x that divided anything I put into it by 2. So x divided by 2. So my inverse function is going to do the opposite. G of negative 1. So g inverse would take anything in I put into it and multiply it by 2. So anything multiplied by 2. So again, I can show you that g of 10 equals 10 divided by 2, which equals 5. And oops, I want to undo that. So g inverse of 5 equals 2 times 5, which equals 10. Again, my input and my output are the same. Nice. Another thing we can do, usually inverses and their functions aren't so straightforward as you can tell just by looking at them if they're inverses or not. So a way we can verify if a function and another function are inverses, we can plug them into each other using composition. And what we should get out after we do our composition is just what we put into it, namely our x. So for example, if I want to know if g and g inverse are indeed inverses of each other, I'm going to take my g of x, that's my outside function, and I'm going to put big parentheses and whatever I put into it divided by 2. And my g inverse is 2x, so that's going to give me, well, 2 divided by 2 cancels, so it just gives me x. So indeed, g of x and g inverse of x composition gives me x. I could also do the opposite. I could say g inverse of g of x. This should also give me x. They undo each other, so it doesn't matter what you put into what. So we can do the opposite. So this would be 2 big parentheses, what I put in there, x divided by 2. Well, I'm going to rewrite this as 2 over 1 times x over 2 to deal with a fraction. It gives me 2x over 2, which gives me just x. Again, I got x to end with, so indeed g and g inverse are inverses of each other, and we know that. So why don't we show you one of the skills they want you to develop is to verify if two functions are inverses of each other. So let's try it. So I'll start off with a function, call it f of x equals 1/2 x plus 1, and my g of x function equals 2x minus 1. So I want to know, are these two functions inverses of each other? Well, what I'm going to do is plug them into each other. So this is going to be f of g of x, right? So I'm going to take 1/2. My outside function is f, so I start with 1/2, put a big parentheses wherever I see an x, plus 1. And what do I put into that? I put g of x into it. So this is going to be 2x minus 1. So far so good. I can distribute the 1/2. So 1/2 times 2 is just 1. So it's 1x. 1/2 times -1 is -1/2. And then I just have this plus 1 at the end. So that equals 1 times x is just x. -1/2 and 1 equals positive 1/2. And I can't simplify anymore, so no, they aren't inverses of each other. I should have ended up with just x, but I ended up with x plus 1/2. Let's do another one where you can actually see it. So we'll start off with, so let's say k of x equals 1/2 x plus 1, and j of x equals 2x minus 2. And I'm wondering, are these two functions inverses? So we do a composition. K of j of x equals, well, what's on the outside? K. So 1/2, there's my variable, so put a big parentheses, plus 1. What goes in that parentheses? 2x minus 2. So let's do this out. 1/2, we're going to distribute this 1/2 to both of them. 1/2 times 2 is 1, so this is x. 1/2 times -2 is -1. Then we're left with plus 1. So -1 and positive 1 is 0. So that just leaves me with x. So yes, k of x and j of x are inverses of each other. I recommend at this point you pause and do the first couple problems on your worksheet that have to do with verifying if functions are inverses or not. Alright, the next thing we want to do is be able to create inverses. To create inverses, we want to just undo what we do with our function. So for example, I have a function called g of x, and let's say it is 3x plus 1. So it multiplies the number by 3 and adds 1 to that number. So to create our inverse, there's kind of some steps you can follow and think about. Really, all we're going to do is reverse our input and our output. So instead of writing it as a function, I'm going to write it as a y equals equation just to kind of help us out. So y equals 3x plus 1. So next thing I want to do is swap my input and my output. So right now my input is x and my output's y. So if I want to swap those, I just switch their positions. So now I write it as x equals 3y plus 1. This in fact is the same procedure we're going to do whenever we create an inverse function. No matter if it's linear, quadratic, exponential, whatever. We swap our input and output, and then we solve for the variable y. So we want to get our y equal to whatever's left. So I do that by just manipulating the function. Subtract 1, draw my magic line. So this is x minus 1 equals 3y. And then to get y by itself, I have to divide by 3. So divide by 3, and I divide everything on the left-hand side by 3. On my right, that cancels out. On the left, this gets kind of weird, but it's doable. X divided by 3 is x over 3, and negative 1 divided by 3 is negative 1 over 3. We can simplify this a little bit further, equals y. X divided by 3, really, if you don't see it, there's always a 1 in front of your variable. So this is 1/3 x minus 1/3 equals y. Now we're almost done because we still have it in equation notation. We want to change it back to function notation. So to change it back to function notation, remember this is a function g of x and we inversed it. So to write our inverse function, it's g inverse of x equals 1/3 x minus 1/3. And there you got it. Let's do another one for practice. So let's do an f of x. Let's say f of x equals 2x minus 1 over 5. Right, and we want to find our inverse function, our f inverse function. What undoes this function? So again, I'm going to write it as a equation notation to make it a little bit easier to think about. So that's a y equals 2x minus 1 divided by 5. At this point, I want to switch my input and my output to make the inverse. So x equals 2y minus 1 over 5. And then I solve for y. This equation right here is correct in that it is an inverse, but it's not very usable yet. So we want to make it usable by simplifying it and setting it equal to y. So the first thing I'm going to do is multiply both sides by 5 because I don't really like that fraction down there. So that gives me 5x equals 2y minus 1. I'm going to add 1 to both sides. Gives me 5x plus 1 equals 2y. Divide everything by 2. This gives me 5x plus 1 divided by 2 equals y. I can keep on simplifying. 5x divided by 2 is 5/2 x, and 1 divided by 2 is 1/2, and that equals y. Finally, I can write it as a function, put it back in my function notation. So this function was f of x, so I want to change it to the inverse. So f inverse of x equals 5/2 x plus 1/2. As a rule of thumb, we do like to simplify these and leave them as fractions. Don't write decimals unless you're writing an answer. Also, down here you notice that I had 5x plus 1 over 2. A simpler version is not to divide, have a compound fraction. It's called a compound fraction. It's better to have two fractions, 5 over 2x plus 1/2. And that's how you do it. I recommend now going to your worksheet and doing the next set of problems. The last set of problems is graphing, so it's the same idea as this, but you graph the function, then you graph its inverse to kind of see what's going on with that. Good luck to you. Have a good day, and that's the end.